Number 5, we got X-rays of wavelength. So we have a wavelength, 0.090 nanometers, are diffracted by a metallic crystal. First order diffraction, so N is 1. That's nice. And it's a 15.2 degree angle. Ooh, what is the distance in picometers between the layers of atoms responsible? All right. So this looks like we got the Bragg equation. What is the Bragg equation? That would be 2, in this case, D, because we're going to be looking for D, times the sine of the angle of theta. I kind of wrote theta backwards here. Let's try that again. There we go. Is equal to N times the wavelength. All right. So let's talk about what these. So D is the distance, and that's a question mark. The angle is the angle. N is the order of diffraction. And wavelength is the wavelength. Okay, so we're looking for D. We have 15.2 degrees. We have 1 for N, so N's going to be gone. And we have 90 or 0.090 nanometers. And if we're going to convert that, I would have 0.090 nanometers. And the best way for some of us, 1 times 10 to the 9th nanometers is 1 meter. And 1 meter is 1 times 10 to the 12th picometers. And so that 9 comes up to becomes negative 9. So that's 3.09 times 1,000 would be 90. All right. So now I think we can solve for D. Rearranging, D equals, N is gone because N is 1, right? So N is gone. We're going to cancel out N. We're just going to have lambda up top times 2 sine of the angle, theta. Come on. Yes, there we go. All right, so D would equal our 90 picometers, 2 sine, and it's 15.2 degrees. And if we do that, I got 171.6, and to 3 sig fig, well, we only have 2 sig figs, so it's 170. I got 170 picometers. Now, if you do this in your calculator, and your calculator gives you like 92.5-ish, you're in radians, and you need to go to degree. So that's the mode of the calculator. Make sure you're in degrees, because we're using degrees here. But that's how we do the Bragg equation in Chem 2. We're not going to dive much into it, but that's about it. That's a nice example.